All right. So in class, we started talking about vectors and we stopped at position vectors. So a vector with its tail at the origin and its head at a point, let's call that point v1, v2 in the xy plane. So the point is in the xy plane. This is our y-axis and this is our x-axis. And this is the point. Make the point green. This is the point x v1. Let's call it v1 v2, v1 v2. All right. Its x coordinate is v1 and the y coordinate is v2. So this vector has its tail at the origin and its head at v1 v2. It can be written as a position vector in this form. Notice that the parentheses are now like arrowed parentheses. I don't know what you call this, but I'll call it arrowed parentheses for now. So if we let this vector, let's call it v, this means that v is equal to the vector v is equal to v1, v2. But not all vectors have their tail at the origin. So let's assume we have a vector u, and u has its tail at the point x1, y1, and has its head at the point x2, y2. We can write it as a position vector by just performing some subtractions. I had written it, but let me write it more clearly. The subtraction will be x2 minus x1 will give you the x component of the vector, and then y2 minus y1 will give you the y component. So this is called, the v1 here is called the x component, and v2 is called the y component. So let me write it again, even though I had written it before. This is the x component of our vector, x component, and this is the y component. All right. So let's do some examples. Let's find the components of the vector PQ. So the vector starts from the point, its tail is at a point P and its head is at a point Q. So let's find PQ. PQ, the vector PQ would be x2 minus x1, negative 5 minus 2. And then y2 minus y1, 1 minus 3, right? So this vector is going to be equal to negative 7, negative 2, all right? And then let's look for PQ again. In this case, PQ is 6 minus 2, which is 4, and 3 minus 5, which is negative 2. Let's try to draw the two vectors, or at least one of them. So, so we have a vector starting at 2, 3. So let's do like that. 2, 3. And then negative 5, 1. So let's do 2, 3. Now let's do 2, 1, 2, and then 1, 2, 3, and then negative 5, 1, 2, 3, 4, 5. I'm going to expand, let's do this. I think we can draw the two vectors. So 2, 3. 2, 3, the point 2, 3 is here. I'm going to do it in green. This point, and the point negative 5, 1 is this point. All right. So the challenge, oh no, negative 5, 1. The challenge is to join these 2 points. Okay, so this is our P and this is our Q. All right, so what I'm going to do now is I'm going to make this a little bigger. See, that's my magic. I can make magic. Oh. Okay, that's good enough. Like the style that. Okay, that's our vector. That's our vector PQ for the A part of the problem. Let's not worry about the B part of the problem, but that's how you get the idea. It starts from P, which is a 2, 3. This is 2. This is 2, and that's 3. X-axis, Y-axis, right? X-coordinate 2, Y-coordinate 3. That's the point. And then X-coordinate negative 5, Y-coordinate 1. Okay. So that's PQ. So let's just be complete. We have 2, 3, and this is negative 5, 1. Okay, very good. So the next thing we're going to look at is the magnitude of a vector. Okay. The magnitude of a vector is simply the length of the vector. Simple. So if you know how to find the length of a line from pre-calc or calculus, it's just finding the length of the vector. So for instance, if we want to find the length of this vector, think about it this way. If you complete, assuming you complete this right angle triangle, think about it. So this would be a right angle triangle, and you're looking for the length of its hypotenuse. Okay, so that should give you an idea. That means you're just gonna look for the opposite. The opposite would be y2 minus y1, and this is gonna be x2 minus x1, right? And then you square this and you square that. You know that the opposite squared and the adjacent squared will give you the hypotenuse squared. So let's use that idea to find the magnitude of a vector in general. So if we're given a point, given the points, oh, you know what? We're not gonna. Okay, we started already. Given the points P is x1, y1, and Q is x2, y2, right? The magnitude of the vector PQ. So remember, this vector PQ is just x2 minus x1, then y2 minus y1. The magnitude of PQ is denoted like that. It's like the absolute value of PQ, and is the distance between P and Q. Okay, and this distance, from having done a lot of pre-calculus, is just the square root of the adjacent x2 minus x1 plus the hypotenuse, plus the opposite, y2 minus y1. Okay, all right, so that is the magnitude of the vector PQ. But now think about this. Assuming we already calculated the vector, the magnitude already. Oh, sorry, the vector already. We're not giving its tail and its head. We just have a vector. So that means the magnitude of any arbitrary position vector, magnitude of the position vector v, and v is v1, v2, is given by absolute value of v, which is, I'm just calling it absolute value, but from now after this we're just going to be calling magnitude v1 squared, square root of v1 squared plus v2 squared. Okay, so whichever you want to use. Okay, now let us do some examples. How about, let's find the magnitude of, so let's say example 4, find the magnitude of the vectors in example 3. So the first one, we find our PQ to be, let's see, what did we get? We got -7, -2. All right, this is gonna, and then that means that the magnitude of our PQ is just gonna be the square root of -7 squared plus -2 squared. All right, so okay, so that means we're looking for the square root of 49 plus 4. That's the square root of 53. All right, B, let's look for PQ. How about this? Let's look for in the first one I just wrote the answer we got. The second one, I'm going to pretend that we hadn't done the problem. We're going to specify what P is and what Q is. Okay, so the vector, find of the vector PQ. All right, so PQ, the magnitude is the square root of x1 minus x2, or x2 minus x1 6 minus 2 squared plus 3 minus 5 squared. Okay, so this is going to give us a square root of 4 squared, which is 16, plus -2 squared, which is 4. So this is 20, right? Square root of 20. What's the square root of 20? Is 2 square root of 5, I think. Check me on that. All right. So that's what we have so far. We learned to add vectors. Earlier using the parallelogram rule and the triangle rule. Now what we're going to do is, now that we have another kind of notation, the position vector notation for vectors, let's see how we can add vectors that way, and trust me, becomes way easier. So so let's look at example number 5. Example 5. we're going to let u be equal to the vector u be equal to -1, and v be equal to 2, 3. Okay. Find the following. Okay. A. Let's find 2u. All right. Find 2u. 2u is just going to be, the vector 2u is just going to be to multiply 2 times each of the components of u, which will give us -4. Oh no. Where did I get -4 from? -2, 4. Okay. Now, we already know that 2u is the vector that is, its length is twice that of u in the same direction as u. That's all. All right. How about, let's look at 2u minus 3v. 2u minus 3v. All right, so that is just going to be 2u, 2 times -1, 2, minus 3 times 2, 3. All right, so this is going to be -2, 4, minus 6, 9, right? You see that? Okay, so if this is the case, then we can just subtract the components. Okay, so we're going to subtract 2. These two will go together, right? -2 and 6. Likewise, 4 and 9. You're subtracting them. So you have, I'm going to write it all out. So it's like -2. Oh no, I want blue. -2 minus 6, and then 4 minus 9. Yes. Okay. I'm just making sure my arithmetic is correct. Yeah. So this is going to be, I'm going to write it over here. This is going to be -8 minus 5. So that's the vector. How about this? Now let's look for the magnitude of 2u minus 3v. So this magnitude is going to be square root of, we already have 2u minus 3v, minus 8 squared plus minus 5 squared. So this is going to be square root of 64 plus 25. I don't even know what that is. That's 89. What's the square root of 89? Can we simplify the square root of 89? I'll let you worry about that. 89. Yes, square root of 89. Okay. Okay, and I just want to remind you of the geometric interpretations of all this, you know. So you have, if you have 2u and 3v, so if you have 2u, assuming this is 2u, for instance, this is 2u, and this is 3v. I'm just making up. Let me not make it straight. So let me not make it, what's it called? Horizontal. So no, I don't want 90 degrees angle either. So assuming this is 2u and this is 3v and this is 3v, or this is -3v, right? So we want, I'm just reminding you of the parallelogram rule. We would complete the parallelogram. The parallelogram para? Do you prefer para or do you prefer para? I prefer para. All right, so, and then you now join this. This is gonna be, so the magnitude, the length of this vector, the length of this is equal to the magnitude of 2u minus 3v. Minus 3v. All right, good. Now, what else are we going to do? What else can we do? Okay, so a very important concept is the concept of a unit vector. Unit vector. So what does a unit vector mean? If you have a vector, assuming you have the vector, this is the vector v, right? And assuming that the magnitude of v is 3. The unit vector in the direction of v is the vector whose magnitude is just 1 unit. The vector whose magnitude is 1 unit. So, and that vector is also parallel to v. So this is a unit vector in the direction of v. So we can just get, I'm going to try to divide this line into 3. Hopefully this is just 1/3. All right. So this is the unit vector in the direction. It's the let's make it a pink vector. Whoa, pink vectors. Pink vector. All right. So this is a pink vector, and it's something is wrong with me. So this is the unit vector. This pink vector is the unit vector in the direction of v. It's very important because now if we know this unit vector in the direction of v, we can get vectors of other length in the direction of v by just multiplying this unit vector by the required length. All right? So how do we find the unit vector in the direction of a vector? Okay? So, okay. All right. So a unit vector is any vector with length 1. So you can see this vector v has length 3. The unit vector in the direction of v has only length 1. Obviously, because of the way I constructed it, you could see that the pink vector is 1/3. The length of the pink vector is 1/3 that of the green vector. All right. So how do we calculate the unit vector? So if we have v, given any non-zero vector v, all right, the unit vectors parallel to v are the vectors v over the magnitude of v and v minus v over the magnitude of v. Okay. Now, if we now want to find a vector that has the same, that has a vector of a given length, let's say the length is c, and it's in the direction of v, all we have to do is to find a unit vector in the direction of v and multiply it by c. So let's do some examples. Let's call this number 6. Okay, so let's consider the point. Consider the point P, 1, -2, and Q. And Q is 6, 10. We want to find PQ. Let's find PQ. PQ, the vector PQ is gonna be 6 minus 1, 5. 10 minus 2, 10 minus -2 is 12. All right, B part, let's find the magnitude of PQ. So the magnitude of PQ is going to be the square root of 5 squared plus 12 squared. I think this is the square root of 169, and I think it is 13. Check that. All right, C. Want to find two unit vectors. Two unit vectors parallel to PQ. So all we have to do is to find the vector PQ over, so the unit vector 1, let's say unit vector 1 is PQ over the magnitude of PQ. So it's going to be PQ is 5 and then 12. 5, 12, oh no, divided by 13. So it's just going to be 5 over 13, 12 over 13. And then unit vector 2 is just going to be the vector that is negative the other vector, 5 over 13, negative 12 over 13. All right? Okay. Now, another question we want to ask, or we can ask, is let's find a vector of length 12. Oh, no, let's do of length 7, right? Parallel to PQ. So all we have to do is this. All we have to do is multiply this unit vector, any of these unit vectors, right, by 7. And all we have to do, so this would be negative 35 over 13. So I'm taking the second one. I'm taking this one and I'm multiplying it. I'm choosing this one and I'm multiplying it by 7, all right? So the vector that's parallel to PQ and has length 7 is the first component times 7, and then the second component. What's 12 times 7? I don't know. What is it? 12 times 6 is 72. 12 times 7 should be 84. Let's see. 12 times 7. All right. 84. 84, negative 84, negative 84 over 13. So that's the vector we want. All right. So one thing I want to end on is two special unit vectors. Two special unit vectors. So, assuming, I'm sure you've seen this before. Let me write it and then you tell me whether you've seen it. So assuming we have our y-axis, we have our x-axis, and we have a vector. This vector just went up to here. This is 1. And we have another red vector. Oh, shit. Let's make it red. Make it a little bolder. So this red vector, and we have a green vector. Okay. So the x coordinate here is 1, and the y coordinate here is 1, right? So the point here is 1, 0, and this point here is 0, 1. So we're going to call this vector I. We're going to call it I. Oh, that's too bold. We'll call this vector I. We're going to call this J. Okay? All right. The board starts from the origin, and at I, let me use appropriate color for J. So at J, the coordinate of the head is 0, 1. The coordinate. And then at I, the coordinate of the head is 1, 0. Okay. So this is very simple to write. These two unit vectors, J or I, let's start with I. I now is, no, one red. Or let's make it blue. I is 1, 0, and J is 0, 1. Okay? So it turns out that any vector on the xy plane can be written in terms of I and J, and it's quite easy. So if you have this example, if you have the vector u, and let u be equal to -2, 5. This is the vector -2, 5. Now look at this. Then, if we can write u as -2, 0, right? Plus 0, 5. See that? And then this means that we can actually write u as -2 times 1, 0 plus 5 times 0, 1. And u, we can now express u as -2i plus 5j. So in general, any vector at all, v, if you have v as any vector at all v, which you have as v1, v2, can be written as v1i plus v2j. All right, we're going to stop here. Okay.